So yes, I have 15 minutes to talk about H5 Pi, and I will do as slowly or as fast as you want me. And fortunately, I cannot help you with the public keys, login, and that kind of things. So if you need to talk and share some problems there while I'm giving, just please speak. I think that's seems to be a more important pressing issue right now. So to start, H5 Pi Python interface to the HDF5 library, I think it's very popular. And I think anyone who's using Python and HDF5 was at some point have some interactions with H5 Pi. But here, this is, as I said, very short tutorial, just very basic things. And so I assume that you are familiar with HDF5 enough and to some degree with NumPy to kind of follow through. But if not, this notebook, what you're looking at, and I hopefully see, is essentially a notebook. Jupyter notebook will be available so you can run through these examples. So what I'll cover are creating files, groups, attributes, data sets, and then reading that content and kind of exploring the content of one HDF5 file. And at the end, I will just briefly throw out this idea of low-level H5 Pi API, which I think is very, very useful and very powerful feature in H5 Pi. Some of the resources, there is obviously GitHub repository for H5 Pi, or its documentation is hosted on Read the Docs website. And the creator of H5 Pi, Andrew Collette, wrote a book. It's now 7 years, I think, since being published, but it's still very useful, especially for those who are just coming into H5 Pi and maybe HDF5. So it's still worth reading. So we'll start, we import some of the packages we need, which obviously is NumPy and H5 Pi. And I wanted to just print out the information I'm using. So this is the Python that I currently run on my computer. And these are the versions of H5 Pi and NumPy that are going to be used in this tutorial. One note about H5 Pi's version, this 1.10, this version that's being used is the latest official release, which is more than a year old. And so last week I went to the GitHub repository. Seems like there is some developments that new version tagged 3.0 is imminent. I don't know how imminent that is, but it may happen to be released pretty soon after this. Nothing really that impacts material in this tutorial, just to be aware that there have been some significant changes between 2.10 and 3.0. So creating HDF5 files, we use h5pi.file class. It's very easy. We create a file with write privilege. In other words, if there is already a file, it'll be overwritten. There are many other options how to create a file, many other settings that you can choose. I have a link here in the tutorial directly to the documentation about that, so please consult it. But some of the things that you can use to find out about the file itself, obviously, what is the file name of the created file, the HDF5 library's driver for the file, the HDF5 library compatibility versions. For example, here we see that the file is compatible with up to 110 file format. And the last one is actually very important, and it's something that's available for all H5 Pi objects, and that's the .name property, which gives you the HDF5 path name of that object. And in this particular case, in H5 Pi, the file objects are also the root group objects as well. And because of that, we can immediately use the file objects to start creating other objects in the file. For example, here, this is example how we create a group named G1. And we see in this output here that its path name is /G1. So it means it's a member of the root group. And also here we see 0 members, which means that the G1 group itself has no other members in itself. Also, H5 Pi by default allows you to create objects at arbitrary level of hierarchy within the file, so you don't have to create groups until to that point. So for example, here we create a group that's 3 levels below root group, and we just use the same command, just one command, and there is the output as well. What's very typical for HDF for H5 Pi is that many of these objects implement Pythonic interfaces so that they're familiar to use to Python users. In this case, these objects expose a dictionary-like interface. So for example, running the len function on these objects give you the number of members that they have. So for example, here we have the root group has two members, which are the G1 and the several group in it. You can also have more advanced methods like keys, values, and items, and I'll try to run this one by one. Let's see how this goes here. Yes. So for example, when you use just keys, you just get the names of these members. If you use the values, you actually get the objects themselves, H5 Pi objects. So this one is first the object for the G1 group, the other one is the object for the several group. If you go with items, you get everything, the name and the object itself is the, oops, sorry. So these are the kind of things that you can do to kind of quickly get the content and the objects. You can also now switch to the attributes. I have to catch up with my time here. We switch to the attributes. Creating attributes is very easy. It's again a dictionary-like interface available through .attrs property on these objects. You just basically give the value and the name of the attribute. And here we're going to create two attributes to the root group. One is the string, the other one is a number. And again, as I said, because it's a dictionary style interface, the len function will give you the number of attributes that the root group has. In this case, it has these two ones. And again, not to run again, we can get all these keys, attributes, and values and items, this kind of outputs that shows you all the kinds of things that you can get regarding the attributes of an object. If you really want to have a very tight control over how an HDF5 attribute is created, all the properties you can create an attribute, there is a method called create that you can invoke and then specify everything by yourself, the data type, data space, and all the other things. Otherwise, H5 Pi would assume that what you want. Also, there is a possibility to modify already created attribute. Typically, H5 Pi would overwrite all the attributes when the new attribute with the same name appears. If you want to avoid that for some reason, you can use the modify method. The only limitation to this approach is obviously that you cannot change the data type and the data space of the new values. Everything is essentially the same. So here we're just modifying this second attribute because it's already a number. So we are supplying 15 instead of 2, which is okay. And we can check now that the value is accepted. So we can see here that there is number 15 here instead of number 2. If we try to say supply a string, H5 Pi will raise an exception because we're now supplying a string as a new value. So now moving to creating data sets, obviously there's a whole, it's a whole new tutorial about these things. The data sets are the main payload, data payload in every HDF5 file. And I include links to the documentation that talks about all these things. Here we're going to show you, for example, how to create a contiguous data set. It's very easy, you just basically say the name. You can provide the data as a NumPy array here, and you can provide the data type, or you don't have to provide the data type, because as soon as you provide the data as a NumPy array, H5 Pi can automatically figure out everything else that's needed to store it. And so here we have just an array of 10 elements, and it's stored here in the G1 group. If you want to create a chunk data set, obviously you provide a chunks keyword where you say the size of your chunk. And again, the above example, similar, only with this, we're creating a larger data set. And we have created this data set now, which is 100 by 200. The chunking, the chunk sizes, it's completely new thing. As I said, can be another tutorial on itself. I include a link to a SlideShare slides where Elena provided a tutorial about this. We're moving on further. How to create, once you create a chunk data set, there are two more options. For example, you can create a resizable data set, and also you can tag each of those dimension sizes of that resizable data set to be unlimited. Obviously unlimited in terms of up to the number that HDF5 library supports. And both of these things are done with the max shape keyword argument. So here the shape says what is the starting size of the data set. The max shape gives the maximum resizable size of this data set. If any of these max shape values, tuple elements, are none, that means that that dimension is unlimited. So here, for example, in this creating an unlimited data set, I'm saying that that first dimension will be unlimited until the second dimension will be 500 elements as its maximum size. And now here I'm just jumping into assigning attributes to HDF5 data sets. And obviously it's the same story like with groups. There's this .attrs property, and again, this dictionary style interface. So you just give the name of your attribute and give the value, and HDF5 Pi will figure out everything else. And here we assign the same attribute name description to 3 already created data sets. Data compression, one of the most popular features of chunked HDF5 datasets is that their data can be compressed. And there is a number of compression methods that HDF5 library supports. Here we only show how to do one that comes built in with the library, and it's Gzip or deflate. And that's all available, supplying the compression keyword named argument. And here as well, as you see, we're creating chunk data set, and we're saying that we want to do Gzip. All the other information about the settings, how to do it in HDF Pi, there is a link in this documentation. So creating all these groups, attributes, and data sets, now we close the file so we can flush the content back to the disk. And now we're going to start reading the HDF5 content. And to begin with, we'll show the output of the file using one of the HDF5 command line tools. This is H5 dump, so it shows you the groups and attributes and data sets that exist in the file. And there is a H5 ls, which is a slightly different one, gives them a bit more information about data set sizes. But you can see what's now present in the file. Open file for reading, we do the same H5 Pi file object. The mode is now R, which means that we can only read the content now. And as I said, there are many ways how you can inquire about the content in HDF5 files. I provide here a simple for loop that goes through a number of groups already existing in the file, fetches the H5 Pi object representing those groups, and then prints out their HDF5 path name, and then prints out those H5 Pi objects for those members. And so when we run it, we basically get this kind of fancy output, but obviously you can do whatever you want with it, how you want to present it. Reading attributes, again, the same thing. We are using the dictionary style interfaces, and we are printing now, which is the root group, and 2 data sets, and we show how their attributes can be printed out. This is another convenience in HDF Pi, that you don't really have to fetch an HDF Pi object. You can go directly, basically starting from the file object, which is the root group. You can provide the full path name to your HDF5 object, and then immediately read its attribute like this. Reading dataset data, because fundamentally HDF Pi is a translator or converter between bytes between HDF5 library and the NumPy data structures in memory. HDF Pi implements a lot of the NumPy slicing array syntax. And here we're going to fetch one of our data sets, this chunk data set, for example. And then there is a number of ways how you can slice its values. The first one here is the traditional one, where you provide a block within an HDF5 data set. An important thing to understand here is that while chunked is an HDF5 Pi object, the output of slicing is actually a NumPy array. So you can continue using this in any way you would use NumPy arrays. There's another way that you can provide sort of a more sophisticated hyperslab selections. For example, here we are selecting every second row and every third column in this selection. And again, you're going to get the NumPy array just with those values. Another one here, example comes, I think it's called, strictly speaking, fancy indexing, because here we're reading 3 rows, but only specific columns which do not necessarily have to be equally spaced in between to provide the values. And this is the output for those. And finally, using the ellipses gives you the entire HDF5 datasets data as a NumPy array. And I'm going to use here only on a small one, which has 10 elements, not to have too much things printed out. And here for the end, I just want to throw this idea of low-level H5 Pi API. I ran out of time, but I just want to tell you that this is a very powerful feature. It allows you to have fine-grained control over basically almost on the level you would have with HDF5C API. And even the high-level H5 API that I showcased up to here is built on top of this low-level API. And in the tutorial, you can see now, for example, how you can get to these values, to these classes and their objects. And I here show you, for example, simple example how you can get the data space status of the chunk data set, and how you can even get the HDF5 identifier for your object if you ever want to do that. And this is the end. So thank you.